Hey students, Mr. Helpern here for the third video. Today we're going to be talking about the mole, and we're going to be talking about why it's important and how do we use that to determine something called molar mass, okay? So, what I'll be doing is writing on the board here, but you'll see it on your screen over there, over in that direction. All right, so as I write, you'll see it. So, to talk about the mole, first we have to use a common example. You see a equation there up on the board in the top, right? The top equation on the paper, right? It's copper oxide, carbon, right? So, as I, oh, is it going to work? Yes. So copper oxide combines with carbon to make copper metal and carbon dioxide. Okay? So that's the basic chemical equation for getting metal out of copper oxide and carbon. Now, when you're going to a factory, right, and you're thinking at the macroscopic level and you want to make a lot of metal, right, we don't typically use the amounts in a chemical equation like this, right? Why? Because we're not talking about single atoms, we're talking about manufacturing. So we need an easy way to describe the amounts of atoms or particles that we're talking about in chemistry, okay? So I use the analogy of a pear and a dozen to explain what a mole is, right? So when I say the word pear, what do you think of, right? Usually think of two of something, two things, right? A pair of desks, a pair of One Direction tickets, or Jets tickets, or Giants tickets, sorry. A dozen eggs, right? Or a dozen cars, right, in the parking lot, okay? A mole is symbolized as MOL. Don't ask me why they just decided to drop off the E. I don't know, okay? But a mole is symbolized as is symbolized as 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd, okay? This number is commonly called or known as Avogadro's number, okay? Amadeo Avogadro worked in the lab and made observations about how many atoms were observed for given reactions, and he came up with this number that is commonly used to describe specifically how many molecules or particles are in a given amount of a substance. So 6.022 times 10 to the 23rd is extremely useful. All right, it's a very large number, but it's to count something like atoms, which are extremely small. So we do need a large number, right? A pair of water molecules, right, is 2 water molecules. A dozen water molecules is 12. 1 mole of water molecules is, all right, 6.022.00000000000. Missing something? Yes. 1, 2, 3, 4, 12, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's 23 zeros right there, okay? Or 23 places, right? That's how many molecules of water is in a mole, okay? We don't typically write it like that. We write it in a convenient way, right? Which is the 6.022 times 10 to the 23rd. This is called scientific notation. So you would want to write it like that, okay? I have a video there that you see a link to. I would check it out. It's the mole song. I highly recommend it. So to figure out how big a mole is, we use an analogy. if I had paper clips, 1 mole of paper clips, okay, and we strung them together, they would go around the Earth 400 trillion times. 400 trillion times. That's a lot, okay? So just to let you know, that is why we use such a large number, okay? Because we're talking about atoms that are very small, okay? However, 1 mole of water, we're talking about molecules, it only equals about 18 grams or 18 milliliters, okay? That's a sip, basically, okay? If you look at any bottle, you'll notice, right, 18 milliliters is not much at all, okay? It's about a sip, so you'd be thirsty, all right? So molar mass, going down, we use the mole because it's a singular amount, and we can figure out how heavy things are now because we can actually measure them with our scales that we have, right? If we're talking about an atom, it's kind of hard. But 1 mole of something is a lot easier to measure, right? So the molar mass is the mass of 1 mole of any substance. It's the mass of 1 mole of any substance. Okay? And you might ask yourself, well, okay, if there is 1 mole, if this is 1 mole, take a look over to the right here, over there on the right, okay? If there's 1 mole of each of those, copper, right, salt, and water, okay, then why do those have different volumes? Hopefully you should understand that 1 mole of each different kind of substance might weigh something more because their atomic weight is different, right? Each atom is different. It has a different weight, okay? And we look at the periodic table of elements for that. That's the other number, that's the decimal on the periodic table, okay? So that's why we use that number. That's why the number is there, okay? So the molar mass of a compound is just the masses of the component atoms. So for example, carbon, its molar mass is 12.0 grams, right? Copper is 63.55 grams, okay? So it's much more. So 1 mole, right, takes up less volume, okay? All right, so the molar mass of copper or carbon dioxide, in this case, going down to the bottom, okay, we figure out the individual atoms, their molar mass. So I look at the periodic table of elements, right? Carbon equals 12.01, right? Oxygen, there's 2 of them. So oxygen, hold on, I'm going to run over to the periodic table. Oxygen is 16, all right? But we have 2 of them, so multiply by 2 to get 32. So what's the molar mass of carbon dioxide? I add both of those together. 12 plus 32, okay? And I equal, let's see, 44.01 grams, all right? That's the answer for that one, all right? So, the molar mass for the second one, okay, you do is you add all of the atoms together, and you add the masses from the periodic table, and figure out the total mass. Okay? Bye.